Hello and welcome back to another festive coding session with Mr. Jacob. Today, joined by our trusty teddy bear glass here today instead of our trusty Grinch mug, we will actually go ahead and prepare the next advent of languages, the 17th day of it to be precise, where we strive to implement every day in the 24 first days of December the same thing in a different programming language. And without further ado, what we will do is we will try and implement the ASCII output of an ASCII Christmas tree, something like that, today in the language Brainfuck. And if you have never heard about Brainfuck, now might be a good time to quickly check out my video where we implement a Brainfuck interpreter in Rust completely from scratch, and even in the end will create a JIT for it to compile it into x86 binary machine code to be executed. However, I will tell you now what Brainfuck is and give you a short introduction so that you can follow if you don't want to watch that whole video. So Brainfuck is actually an esoteric programming language, and we can do something like hello Brainfuck. I don't even know what the correct file ending for Brainfuck would be, so I will just write it out there. And Brainfuck is actually a language that only consists of the following characters: open and closed square bracket, a dot, a minus, a plus, a open angle bracket and closed angle bracket, and one character more that I can't remember because it is for a feature that I never use. So there is one more character that I don't use. If you are interested, look it up. So these are actually all of the things that this language consists of, and we will go over what they do shortly. However, this is actually everything that we use to write a program. What we can do is we can write anything else. So I could do something like anything else. And this would be a valid Brainfuck program because everything that is not one of those specific characters is completely ignored. So comments are just realized by simply writing out text that does not contain those characters that I have just shown you. And as I've said, we have written before, let me end this, we have written before our own Brainfuck interpreter, and I've just compiled it quickly and copied it into this directory here. And what I have done as well is I have searched and located some of the ASCII codes that we actually need for the characters that we need to print out, because I will not be able to remember them top of my head, and I did not want to make this video longer than it must be by then including the search for them. So we know that a new line, for example, is an ASCII character 10. It is in hex 0A, a slash is a 2F in hex, and a 47 in decimal, and so on and so on. So what we need to draw our Christmas tree actually is a new line. Actually, that's not a new line. It's not a carriage return. It's a line feed, however. For our purposes in our terminal, that will be the same thing. We have a slash, a backslash, a dash, which is kind of this thing then, and we have a pipe, which is this thing, and we will have the space character. And those, we will need those actually, and I can actually take them now and copy them over to our, wait a second, what did I change there? I have no idea. I can copy them over to our Brainfuck program because, as we have learned, all of those will be just treated as a comment. Now let's take a look at a quick Brainfuck program. I can't easily do something like the usual thing where I print out something like hello Xmas, because that would already take up a lot of time to write. So let's do something maybe very simple. Let's do something that I can use to explain to you the basic things that we do here. The basic operations that we have is the Brainfuck, when it started, it gives us a continuous memory area, which is all zeros. So we have a lot of memory cells, which are all zero by value there. What we can then do is, with those operations that I already showed you, something like that and that and that and that, we can actually manipulate those values. So we can actually use the angle brackets to move forward in our address space. So we always manipulate it byte-wise. So we are writing or reading a byte. And what we can do is actually, currently, when we are at memory address position 0. If I do that character, we will actually be at memory position 1. If I do that then again, we will be at memory position 2. If we go back, we are now at 1 again, and now we are at 0 again. If we do a plus, it will simply increment the current memory address. So our memory position 0 now would not be the value 0 anymore, but the value 1. If I do a minus, it will decrement the value, looping around at the byte point. So if we go below the 0 point, it will simply start at 255 again, because that's the value that we can in a maximum store in 1 byte of information. If we do the dot operation, it will actually simply print the ASCII value, or the value that is stored in the current memory address that we are at, to the screen as the byte value. So if you put, for example, something in like the 47, it will simply print out a slash then, because we are then printing out that memory value. And then we have those angle brackets here, which actually allow us to loop things. So what they do is they check in the beginning, before they are started, this first angle bracket here will only be entered into if the memory address is currently, or the value of the current memory address is not 0. And the same thing will be done with the end bracket, but in the reverse. So it will only left and gone something like here, for example, if the memory address, the value of the current memory address here is 0. Otherwise, it will simply jump back to just behind the first square bracket and repeat all the instructions in those brackets again. So what we could do, for example, is if we wanted to print out slash, we could do something like we do, let's see, we do 47 plus symbols here. So now we have 47 plus symbols here, and then we do a dot. So now we should actually print out a dot here. So let's quickly check that we actually are doing that. And as you can see, now we have printed out a slash. And in order for us to not always repeat this gigantic amount of pluses and stuff like that, let's create a memory address for each of those thingies here, those characters, more or less. And usually what I do in such a situation is I have some sort of, what did I do there? I have some sort of scratch space in before. So what I do there is I have something like, for example, from temp 0 to temp 10, for example, we could have some values there. So actually 10, or better said, including the 0, 11 memory addresses that actually we do not use for our data storage, but only for our internal operations. So what we are going to do is we are simply going 10 times forward, aren't we? So let's do that. Let's do that by hand here now to just make this sure. So now currently we are at memory address 0. Now we are at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and we want actually to go to 11. So now we are at memory address 11, so that we can now, for example, put the new line there. Yeah, so that is actually something that we would store somewhere, or would like to store somewhere. However, maybe we want to store something else first. If you remember from our Christmas tree thingy here, we need those groups here, those kind of levels that our tree consists of, and usually we make those configurable in our applications. And I would like to make this configurable in our Brainfuck application as well. So here we have currently 3. So let's maybe start with that. So let's first of all now in our 11th memory address here, and I will simply put that 11 there. It's just, as you know, it's just a comment. It's not part of the language, it's just a comment. Only all of those crazy looking characters are part of our program, and we will prove that in the end by simply removing all of the comment characters, so all of the text and everything that I've written there as well, and the program will still run if we are successful creating that, because it's kind of complicated to do that. So let's at the 11th position maybe create something that we are commenting with as groups. As I said, it's only for us to be to know better what we are actually doing there. And I guess we could say that we want this as a 3. So let's do that. So now we want that, which means we are at the 11th position here because we went forward 10. We went forward those addresses here. So what we need to do is we need to put actually 3 pluses there. However, I usually like to be a little bit or for me to make it a little bit easier for me to reason about at which addresses we are, after each operation that I've done, I usually tend to go back to simply to the 10th entry, so that we are actually at our 10th memory address here. So what I had just done, I removed one of those go forward signs here, those angle brackets, and I will now put it in front of here, because what I want to do here now is and signal here, okay, go one forward, so go to 11, because all of our operations always intend to start at the cell 10, go to 11 and add 3 to it. So this cell will then actually be 3. Okay, now that we have done that, we can actually go ahead and create some addresses that simply contain those values. So the 10, the 47, the 92, the 45, the 124, the 32. So how can we actually do that? You know, we simply do that again by just going one forward. So this will actually be then the 12. This will be the 13. This will be in the end the 14. And as I've said before, I'm just doing this comments here in order to allow us easier reasoning about what we are further doing there. So the real code is actually this. So I go forward 1 and then I need to go to value 10. So increment 10 times. So I can actually do that by putting 10 plus signs there. And I will do the same thing with the 47. So wait a second, like this. And I will do the same thing with the 90. Did I now do 92? Wait a second, no, 92, add plus. And of course we need to go one. We need to go one further in the address space. Otherwise, we would have just added it to cell 13, which we did not want to. So the same thing here, but we need 45 plus signs here. And then we have the pipe. This will be obviously the longest one. So let's quickly do that. 1, 2, 4, add plus. And there we go. We have an enormous amount of pluses there now. And let's see now that we do something like the 32 add plus there as well. And now we have all of those memory addresses in our Brainfuck interpreter filled with the corresponding values. So in order, for example, for me to print now a dash, first of all, after I've set this up, as I've said, I always want to return back to address 10 actually. I'm simply going back to address 10. So currently we are at address 17. So now we are at 16, at 15, at 14, at 13, at 12, at 11, and at 10. So this will actually kind of conclude our setup of data. Now, if we want to, for example, print out a dash, we could simply do something like we move up 5 memory address areas. So let me do that. So we go to this address, then we print that, and then we actually, come on, we need to go back again. So now we are at the 10 again, and we should have printed, if I done everything correctly, we should now have printed a minus character to the screen. So let's quickly see that we have. And as you can see, we have. So our program correctly set up all of our values here, and it then in the end printed that out. So now how can we actually go ahead and print our tree groups here? We are using loops for that, and we are using our temporary address space, which we have here in this this area before all of this data. So how would we do go ahead? What we want to do is actually print those kind of groups first. And what we need to do for that, we first of all need to print spaces here. And those spaces are actually quite easy to be printed because they are the amount of groups that we actually want to print in the whole minus the group, where a group always is this one of those zigzag creating pairs here. So minus the index of this group. So we start at 0 and go up there. So we need to kind of implement that in order to know how many spaces we should print. So what we want to do first, of course, is we want to kind of print this tree or iterate over our number of groups here. Because, yeah, we kind of need to, because we want 3 levels deep, so we need to iterate the groups. So let's start with one of our conditional thingies here. And as we want to actually operate on groups, on this groups value here, what we do is, first of all, we go to index 11, because we are at index 10 here. So we go to index 11 to check, as we have learned, that this is not 0, because if we have 0 groups, we have nothing to do here. So now we are actually in this group cell, and then now we can actually do this loop. And we can do this by, first of all, preparing a copy of this groups data, because what we can only do in Brainfuck is every time we want to modify something, or if we want to actually only loop over something, we are actually destroying the value itself. It simply can't be done any other way. So what we are actually doing is we are copying the value by looping over the value and storing it to 2 memory cells. And then in the end, we can use one of those to restore the original value. Let me show you what I mean. I want to copy, essentially, our groups information to temp 10, to our temporary cell 10. And I'm going to do that via the temp 9. So we are using temp 9 as a real temporary storage while setting temp 9 to this information. So what we now do in order to reach our target, we will go ahead and create another loop, because they can be nested. So what we do here now is we decrement our groups, our cell 11. We simply decrement that. And then we go back 1 to temp 10 and we increment that. And we go back another time to temp 9 and increment that. And then we go forward again to temp to our groups variable. So this loop will actually run as long as there is some value still there in this group's memory address here. And as we are doing this, we are essentially copying this memory value, this 3, into the cells temp 10 and temp 9, so the memory cells 10 and 9. Because we are doing that for each loop, we are doing that on both of them. So once we have actually finished that, we can actually go ahead and move to our temporary cell, so to temp 9, and then we do another loop where we decrement that temporary cell 9 again, and we go further up again into our memory cell 11, which is our groups here, and we increment those again. And then we go back again to our temp 9 value. So what we have now done is we have now our temp 9 value, which is 0 again, and we have restored our groups data, so it's still in there for us to be used. Now we need to go back one element here. We need to go forward one address here, because we want, as always, after each of our operations for easier reasoning, to be at the temp 10 at the 10th cell of our data. So now we actually have a copy for within our loop to be worked with here without destroying this outer loop. What we now need, however, is we need, as I've said, to do something like we need to print spaces and the amount of the iteration minus the group. However, and we actually need to, do we need to multiply this by 2? No, not yet. We only need this amount of spaces actually. So the interesting part is that we are already going to decrement the groups information that we actually have here once we actually iterate that. So we have already the correct information here because we have copied the modified value here. Let me only quickly check something, because we had moved to group 11 here before starting here our operation. So we are actually doing that here, thinking about the case where we are in the memory cell 11. However, for better and easier debuggability, I would like to do it that way. So we start out by going back to cell 10 and then immediately go up to 11 again. It's just an operation that we waste there. However, it makes things and reasoning for us a little bit easier. In the end, however, at the end of this loop, we will always want to go from our end, so our 10th cell where we are trying to be at after each of our operations, again to the groups thingy here, and we need to decrement this by 1 to simply do the loop and do it 3 times in the end. So now that we have actually copied this value over, we are going to use this value to output spaces. So now what we want to do is we want to output spaces, the amount of that we have actually stored now in our temp10 variable where we actually are. So what we can do is now we do a loop where we decrement temp10 here. So print temp10 spaces, something like that. So we decrement now temp10 and we actually then implement the space printing here, which would mean we need from cell 10, we need to go up like 7 times to group 17. So what we do here is 11, 12, 13, 14, 15, 16, 17. Then we print and then we go back. We go 16, 15, 14, 13, 12, 11, 10. So now, and we do this in a loop. So now it will simply go here again and do the same thing again. And now we should actually have printed for each of our groups here, one line of spaces with the correct size, so to speak. What we need now to kind of validate this is after each of those iterations, we want to print a new line. However, actually printing a new line is quite easy for us to do. We only need to go to 12. So what we do here is we go 2 forward, we do a print, and we go 2 backward. And now we have printed a new line. So let's save this, and we won't see a lot of things now if we do that, because obviously we have the right amount of new lines here. However, we can't really see spaces. So let's maybe just pipe this into hex dump type C, for example, where we should now be able to see what we expected. We actually would like 3 spaces, then a new line, then 2 spaces, then a new line, then 1 space, and then a new line. And that's actually more or less exactly what we are getting here. So yeah, that seems to be the correct thing to do that. And then I would have expected actually another new line at the end. Wasn't there? Maybe I just did not see that. Maybe this was not dumped out. I don't know. We'll see in a second, because I would have expected that there is one without spaces there. However, oh no, we are not printing a new line at the end. We of course need to print a new line at the end of our program. Yeah, that kind of makes sense. So now it should be kind of correct. Now I did something wrong here. So we are here. Oh yes, after this loop we are at address 11. However, we want to be at address 10. So let's end this loop like that. And now, yeah, as you can see, now we have this extra new line at the end. So we have now the spaces. So now what we need is a slash, actually. So we don't want a new line, we want that later, we want a slash. And the slash is printed the same way a new line is. However, we are going to memory address 13 here and back again. So now we should actually, and I see I could have just done that to show you without all the hex dump, because it wasn't that much of that much work. We can now see that we have those correctly positioned slashes there. So let's see how we actually are going to print now the inner spacing part. So because what we need here is we need not only the spaces before the tree, but we need the spaces here in between. And the spaces there in between are actually, let me see, where is this? We should have done this. This is actually, we should have commented this, print space, something like that, so that we know what we are actually doing there. And then what we now want to do is we print inner space, or we can actually think about or reason about that. Because what we need to actually print in terms of spaces is the groups amount, so the amount of groups that we are actually having to be rendered out in full. So so if we have 3 groups to be rendered out, we need the sorry, not the groups. What we need is what we need actually is the level that we are in. So this is actually group 0, this is group 1, and this is group 2, so to speak. So what we actually want to do is we need this level. So we need to know 0. So here we are doing 0 spaces. And this next line we will take a look at in a second. It's quite easy if we have the first one. In the second iteration, we actually want the level times 2. So we want 2 spaces. In this one, we want the level times 2. So the level is 2 here. 0, 1, 2 times 2 is 4. So we want 4 spaces. So this actually is based on the level that we are currently at. So we need kind of the current iteration level. However, we don't have that. The only thing that we have is the number of groups that we have already iterated and the number of groups that we started with. And actually, we are destroying the number of groups that we have started with. So we may need to actually store these groups somewhere. So I guess what we want to do is now, let's do something before. Let's do something like store groups at temp, I don't know, 7, for example, because I think we will not go down there, otherwise we will see. So what I now need to do is I need to do the same more or less than I did here. So I can actually copy this and give it here just to make things a little bit easier for us. And we do that, we store the groups at temp 7 via temp 8. So we are simply using temp 8 as a temporary variable here. So what we essentially need to do is we need to go to our groups. So we are going one up to our groups memory address, which is 11. Then we go down there. Then we need to go down to memory address 8. So we are currently at 11. So now we are here at 10, at 9, at 8. Then we go one down further to 7. We both of them increment them, and then we go back actually to our 11 here to just decrement that further. Then we are going to our memory address 8 again, to our temp 8 memory address, which would mean we need to go 3 down. Then we decrement that. We go back to our memory address 11, and then we go back to our memory address 8. And in the end, we are at memory address 8. So to go back to the 10, we need to add 2 to our memory address. So now we have actually stored the groups at temp 7 via temp 8, which is kind of what we wanted to do, because now we need to know this information here, because what we now need to do is we need to kind of calculate the original groups amount, which we have now stored in temp 7, yeah, minus the amount that is still in our memory address 11, which is groups here, and that we need to take times 2. And we will do that actually. So let's quickly see. We start with the biggest value that we want to actually subtract something from. So what we do here is we do copy temp 7. So this is actually the length. So where we started. Copy temp 7 to temp 10 via temp 9, for example. So we are doing the same thing as always. We are at temp 10, so we want to copy temp 7. So we go back there, then we start our loop, we decrement that thing, then we go to our target, which in this case would be temp 9 first. We increment that, we go one further to temp 10, we increment that, and then we do we go back actually to temp 7 again, which would be then something like that, exactly. And now we have actually transferred the value of temp 7 to temp 10 and temp 9. We need to now transfer it back from temp 9 to temp 7. So what we do is we go to temp, we first of all go back to temp 10, then we go to temp 9, just for clarity here. We could have just, of course, combined this into this. However, I find this easier to read and reason about. Then we start again. We go by decrementing temp 9. Then we need to go back to temp 7 again. We need to increment that one, and we need to go up to temp 9 again. And once we are finished here completely, we go one up, and we are now at temp 10, and we have in there the value of temp 7 copied. And we have restored temp 7 after that. Now we need to actually take every value that we currently have in our current iteration cycle, which is groups here, and actually subtract it from our temp10 variable here. So how we can do that is actually by copying it first as well. So copy copy groups to temp9 via temp8, for example, which is now free again to be used by us. So what we do here is we go to the groups here, so 1 up, we go then minus there, we go then to temp9 and add it there, and we go 1 again to temp8 and add it there, and then we go back three addresses to the side, and so we have copied it to both of those. So now we actually need to go to our temp8, so we go back, wait a second, 3. Yes, we do, don't we? Yeah, we go back 3, so now we are at our temp8, I guess. Wait a second, did I do this right? So wait, after this, we are actually at groups, so at memory address 11, and we want to actually go to 8, so we want to go 10, 9, 8. Yeah, that's right. Okay, so now then we do a loop. We decrement by 1. We then go ahead, and after we have decremented this value in the temporary thingy there, we go back to 11 actually, to the groups, and restore the groups. Yeah, exactly. We restore the groups, and then we go back to temp8 again, and then we need in the end go back, to cell 10. So this is actually why I say I'm always trying after each operation to go back to cell 10, because that makes reasoning about all of those cells a lot easier there in the end. And it kind of makes all of those operations kind of atomic and not depend on each other. And if you are still following me here, once we have the first group printed, this will actually go a lot faster. So if you haven't already switched off this video because it's simply completely crazy what I'm doing here, then I think that's great, and I love you for it. So if that's still the case, please give the video a thumbs up and leave me a comment maybe that you have actually followed this up until this point, and we will do this. We will finish this up, and if you are just going to end this video more or less now, then take a look at the finished code. It will be committed to the repository. So so now we have actually copied the groups value to temp9. What we now need to do is we need to go into temp9. So we need to subtract temp9 from temp10. So we copied our full count into the temp10 variable before here, and we now need to kind of subtract from we need to subtract temp9 from temp10. And how are we going to do that? We are going into cell temp9, that's where we are here, then we are doing a loop. We are decrementing temp9, and we are going to cell 10 and decrement that again as well for each of the decrementations that we are doing on temp9. Then we are going back to temp9, and then we are in the end going to temp10 again. Now we have actually subtracted the value of temp9 from temp10. What we now need to do is we need to multiply temp10 by 2. And the easiest way to actually do that again is again by a temporary cell. So multiply temp10 by 2 via temp9 again, because temp9 is now, we don't need that anymore. We have actually, through this operation here, nulled that again, so we can use it again. So we want to actually multiply that by 2. How do we actually do that? It's kind of easy. We are going ahead. We are already in temp10 here, so we are iterating. We are subtracting, so we are looping the amount of value that is in temp10 there again. Move to temp9, 2 times add, so kind of for every iteration cycle in temp10, we will add 2 to our temp9 value. Then go back to our temp10 for the check here. And now we have actually in temp9 the doubled value of temp10. What we now need to do is easy. We go to temp9, we actually subtract there, we go back to temp10, simply add that up until the value that we want here, go back to temp9, and then in the end we go to temp10 again. So what we actually now did is we simply transferred or moved temp9 to temp10 because we can't easily copy without a temporary variable. So we doubled the value up in temp9 and then used temp9 and moved it to a memory address location 10. So now actually we have n or iteration count times 2 in temp10. And now so we can do something like print inner spaces. So now we can actually use inner spaces from temp10. So what we can now do is we can now go ahead and use temp10 as a counter to print spaces. And also, as we already know, is spaces are in memory cell 17. So what we need to do is we need to go here 11, 12, 13, 14, 15, 16, 17. Then we output, then we go back 16, 15, 14, 13, 12, 11, and we are at 10 again. And so we do that until temp10 is actually empty. Then we need to print a backslash. That's actually kind of easy. It's like in memory address 14. So what we do is simply to go 11, 12, 13, 14, we print and we go back those 4 entries there. And then we do this new line thing again and we have that. And now let's see if I didn't something very wrong. We should have the basis for our Christmas tree. And you might not believe it, but that was the hardest part actually. So, because what we can now do is we can kind of copy all of this code here. So maybe I should comment this first. So print, that's actually a backslash, isn't it? And this is print new line, because what I don't want to do is lose track of that. So let's more or less copy all of this. Let's do here something like, wait a second. Interesting. I have no idea what I just did to my editor. However, okay. So let's see. So what I want to do actually now is I've copied that. I wanted to actually do something like put something here like line 1 of group. And there we put something like line 2 of group. And the second line actually is kind of easy here with this tree. So we have now printed all of those first lines of the group. And the second line actually is only 1 space less to the left in the calculation. And in this calculation, it is simply going ahead and taking the n, so the current iteration value, -1. So, sorry, +1. So it's already taking the next one. So as you can see, here are 2 spaces and here are 2 spaces again. So we only need to do the following to now print the second line. We simply go ahead and print 1 less space. So what we do here is now spaces -1. So essentially we have that in 10 and we are in 10. We simply do a minus. And so we have the right amount of spaces there. Then we got ahead and copied our length here, and then copied our groups maybe there and subtracted that. And that is actually our iteration value. And before we are actually multiplying that, we are actually going to add 1 to it. So add 1 to iteration value in temp10. So we simply do, what do? We do a simple plus here before doing all of that shenanigans. And as you can already see, again, that is the reason why I'm already going to try and reset back to the same memory address in between all of those operations, because it makes something like this a lot easier. So now we should actually have already created, if I didn't something horribly wrong, and I hope we did not. Okay, I did something wrong there. We should have created our Christmas tree already, so I guess there is something wrong with our inner space calculation. Something I did wrong there. So maybe, yeah, I somehow copy this line in there when hitting the save, I guess. Okay, now we have the basis for our Christmas tree in Brainfuck. So what we can now do is we can kind of leave our loop here, because the next thing that we need to print are all of the dashes. So if you remember, if we go to the README, we now need to print this section here. And this section here is actually something that we can kind of easily calculate. It is the amount of groups, so the amount of initial groups, in this case 3, times 2 plus 2. And that's actually something that we already know how to calculate, don't we? So we can kind of take this code out of here. Like, we want to duplicate the original groups value, which is in temp 7. So we are now going ahead and taking that simply because we need that. We put that here. So copy temp 7 to temp 10 via temp 9. We did that. So now what we need to do is we don't need to subtract anything from it, but we need to multiply temp 10, where we copied this thing, by 2. So I guess we will do that. So let's take that and let's copy that. So now we actually have the value of the original groups count times 2 there. And now we need add 2 to temp 10, and we simply can do that with 2 pluses. And now we need to simply print dashes. And we need to print dashes the amount of actually the value that we now have in temp 10. So print dashes amount of temp 10. And we do that the usual way. We decrement our calculated value here. We check that the dash is actually in 15. So we go 5 forward. So 1, 11, 12, 13, 14, 15. We do the dot. We go 14, 13, 12, 11, and we are at 10 back again. And now we should actually oh, and we need a new line, of course. We can copy that as well. We already wrote that out, didn't we? So we take the new line here, and now we are actually going to print that. And as you can see, we have our dashes. So now what's the next thing that we need to do? We actually need to print the trunk, and that is quite easily done as well. We simply go ahead and print the number of initial groups here, spaces, and then 2 of those pipe characters there. And we need to do that actually 2 times. So we essentially do the same thing again. We take the original group information there again, because we need that, and we have that now in temp 10. So now we only need to print spaces the amount of temp 10, and we can actually take that from here as well, so I don't need to count again. So now we should have the spaces. What we now need to print is we need to print a pipe. So we need to print a pipe, and we need to print pipe 2 times. So what we essentially do first now is we simply put 2 in our temp 10 register here. Then we do a loop where we decrement temp 10 again, and then we print a pipe, which is actually, where is it? It is in 16. So we simply go ahead and do 11, 12, 13, 14, 15, 16 dot 15, 14, 13, 12, 11, 10, and we are back there again. And now we should have two pipes there. And what we need now is a new line. However, we need that 2 times, don't we? So what we can actually do is we kind of prepare another variable there, for example, temp 9 here. So prepare temp 9 with 2. And what we do there is we go back 1, so we are at temp 9. Then we do plus plus. And then, or we could do something like loop 2 times via temp 9. That is properly more what we want to do here. Then we go ahead, we subtract 1 here, and we put everything of that into a loop, because we did not use temp 9 in here. We should be fine, and this should actually be executed 2 times. And after that, we of course need to move back to temp 10, and before actually we start this operations here, we need to move to temp 10 as well. So I'm sorry, we don't need this. We needed it here. So we need to decrement address 9, then we move to 10, and at the end we need to move to 9 again to complete the loop, and at the end we need back to 10 so that we are at the same position where we were before. And if I done this right, it should actually print as I must have forgotten. I just kind of ate up the new line somewhere, I guess. So I needed this print new line here as well. So that's actually interesting. Where is our we need, that's actually a problem. Okay, so we need to obviously do this 2 times for the spaces, so we need to move this inside here, this preparation of temp 10 via temp 9. However, we could maybe do it via temp 9, so temp 8, so that we can actually use temp 9 for our loop. So let's do this via temp 8 by simply going then, we are starting at 7, then we are only going 1 forward, then we are going 2 forward, then 3 back again. Then we need to move to, let's quickly see, we need to move, we are at temp 7 here in the end, and we want to go to temp 8. So we are just going 1 up, and then we are actually at temp 8, and now we need to decrement temp 8, move 1 down to temp 7, fix that up, go here, and now we are at temp 8, so we need to go back to temp 10 again. So maybe I've done that right, and now it prints us a Christmas tree in the form that we wanted it. So ladies and gentlemen, we have successfully written our Christmas tree program in Brainfuck. And it took us only 45 minutes to do that. And just now, to prove to you that we can actually do this, so that our program here, that all of this are really comments, and that it only consists of all of those bracket and angle bracket and dot and something notations, I will simply go ahead and remove those by simply doing something like I'm actually let me just, to make sure that we do not delete that now, let me copy hello brainfuck to something like hello real or hello no comment brainfuck. And now let's do something like hello no comment brainfuck, and we simply put that through a set of regular expressions which essentially filter out everything that is not one of the brainfuck characters. Then we are removing every new line, and then we are formatting this with 40 column width. I've prepared that beforehand, so we can do that, or we can simply output that. And this is now our, this is now the whole program that we wrote. And as you can see, it's not even that large. So it seemed a lot larger through all our comments, but it's not that absurdly large. This is mostly here preparing all of our ASCII characters, and then this is essentially here our real program doing all of the work. So what I can do now is I can kind of maybe take our hello brainfuck program, and I just put that into our hello no comment brainfuck as an output there, and then I hope that I now did not destroy anything. Okay, there's our original program, and we want hello no comment brainfuck, and this is our program. And now if I do Rust brain and I give it our hello no comment brainfuck file and I press enter, we have still our Christmas tree. And by the way, the best thing now is if you know where to edit it, because we have written it, we know that this 3 pluses here at the beginning are actually the number of groups. So if I change those 3 pluses here and change them, for example, to 8 pluses, so that's actually the only thing that I've changed now, I store the file and I run it again, and now we have a larger Christmas tree. So maybe we should do this only 7 times to make it fit our terminal still. And there we are. We have a dynamically configurable Christmas tree in Brainfuck. Feel free to take this program and use it somewhere, and maybe make all of your coworkers look like like you are kind of crazy, because I think we all are here if we think this is cool. But nevertheless, I love it, and I hope you had fun seeing me, even though this is by far, I guess, the longest session of this Advent of Languages, seeing me do this actually in Brainfuck and implement this tree in Brainfuck. And I hope that you will join me in the next session tomorrow, when there is another language where we actually do our Advent of Languages there. And please, if you have gotten this far, really leave me a comment to the video. I would be amazed to hear that somebody actually got this far and watched the whole video. And please tell me that you did. I would love to hear from you, and give this video a thumbs up and maybe subscribe to the channel. And I hope to see you in the next one. So bye.